Well, good afternoon again, you guys. I'm here to do part 2 of our chapter 2 unit. I needed to explain to you a few things about angles in standard position. Um, what are quadrantal angles? What are coterminal angles? And then to begin to teach you how to use a reference triangle to find your 6 trigonometric functions. So those are our goals for today. Now, this is still part of chapter 2. Our first lesson, which will consist of several parts. So you may want to go back and watch several of these pieces again if you need to. So this is still section 2.1. In if any of you happen to have your book, it's going to be 2.1, 2.2, and 2.3. Those are the 3 sections that we're going to cover out of chapter 2. So these are really all a part of the same note packet that I have sent you via email. Okay, so let's get going. Angles in standard position. An angle is in standard position if its initial side is along the positive x-axis and its vertex is at the origin. Okay, so if I draw an angle, it asks me to draw a 45-degree angle in standard position and find out one point on the terminal side of the angle. Okay, so in order to draw an angle in standard position, I need to start on the x-axis. So this is the positive x-axis. Its vertex is at the origin. And if I want to draw a 45-degree angle, remember that that's going to split this 90 in half. Okay, so this is going to be a 45-degree angle here. Remember, we move counterclockwise when we draw angles. So I've drawn a 45-degree angle, and it asked me to find out one point on the terminal side of that angle. Okay, so what I'm going to do in order to find one point, I'm going to come to my initial side, and I'm just going to draw a right angle up. You can do it wherever you want to. And what I look at when I look at a coordinate that's on this terminal side, I have 1, 2, 3, 4, 1, 2, 3, 4. So this coordinate would be 4, 4. And that is a point. It asks for one point on the terminal side of the angle. Now you can see you would have also, if you were following, 3, 3, 2, 2, 1, 1. Those would all be coordinates or a point on the terminal side of the angle. You know that has to be true according to the rules of your 45, 45, 90-degree right triangle, that whatever this side is, this side has to be the same length. So remember that it was an x, and an x root 2. So all of those things still have to be true. Even as we continue into our reference triangles, which we're headed onto right now. The next kind of angle that we have are what are called quadrantal angles. And a quadrantal angle is an angle in standard position whose terminal side lies on one of the axes. So we've talked about what angles are in standard position, but we have never mentioned what happens if one of our angles happens to fall exactly on an axis. All right, so let's go with the blue here. So if I draw my initial side, and then I draw the terminal side on the actual axis itself, that is called a quadrantal angle because it doesn't lie in any quadrant. It's not in quadrant 1, 2, 3, or 4. It's actually on the axis itself. So those are called quadrantal. It asks us to list the measures of some quadrantal angles. So if I list some of these quadrantal angles, well, let's see. I can have a 0-degree angle. So let's see if the initial and the terminal side are on the same ray, then I have a 0-degree angle. If I go to the first or the y-axis, I'm going to have a 90-degree angle. If I go from here to here, then that looks like I have a 180-degree angle. And then let's say I go from here to here. So all the way around to here, that's 390s. And that's going to give me 390s will give me 270 degrees. And then if I go all the way around, so let's say I start here and I go all the way around and end up back on top of where I started, so the initial and the terminal are the same side, then I could have a 360-degree angle. Now, I'm not limited to stop there. I could go around again. So if I started around again, I would have the 360 plus the 90, which would give me a 450-degree angle, et cetera, et cetera, et cetera, et cetera. So you can keep going, et cetera. You can keep going as long as you want to. You can spin around the axis as many times as you'd like. So that's totally up to you. And you just need to make sure that you know that that's possible. Next thing we want to look at, I feel like I should stop and say, are there any questions? But okay, you'll have to email me or give me a Google Hangout if you have any questions with this. Next thing we want to look at are what are called coterminal angles. Okay, coterminal. So coterminal means co means with and terminal means end. So it means they are ending at the same place. So these are two angles having the same terminal side. Perfect. So I have a couple of them that I want to ask if you know. It asks, are these two angles considered to be coterminal? Do they end at the same spot? All right, so what I'm going to do is I'm just going to draw an axis really quickly, and you're going to be able to do that yourself. The first one I'm going to draw is a 60-degree angle. So I'm going to start. Here's my initial, and a 60-degree will go about here. So we'll call that 60. I'm going to go with green for the next one, and I need a negative 300. Okay, so I'm going to start it at the same spot. So the initial always starts at the positive x. And then if I do a negative, remember my positives are going this direction. My negatives are going this direction. So a negative degree angle, so there's 90, 180, 270. And if I wanted to go to 300, remember that that's 30 degrees. This will be a little 30-degree angle here. And they are actually going to end at the same point or at the same, they have the same terminal side. So when they ask me, are these two considered to be coterminal? The answer to the first one is yes, they are. Now I'm going to go on to the next one, and I want to know about the negative 20 and a positive 280. All right, so I'm going to draw me another axis. I'm going to put on here a negative 20-degree angle. So I'll do the first one in red. And, these aren't exact, but I'm just getting close. A negative 20 would be about here. Okay. So a negative 20 would be, remember, we've got to start down 20 degrees. It means going around the other direction. So this is the negative direction. If I moved in the positive direction, so let's go with green again this way. And they wanted me to go 280 degrees. All right, so once again, they're going to start at the same initial side. There's 90, 180, 270. And it wanted me to go to 280. So 280 would mean that there's 10 degrees extra that is used in here. Do those two stop at the same spot are they sharing the same ending side or our terminal side? And then the answer to that is going to be no, they do not. They are not coterminal angles. So one of the things we're going to ask you is to determine if two angles are coterminal. Here, we're going to give you a chance to just pick a couple. So you can pick anything you want. Can you name a pair of coterminal angles? So I'm just going to pick a couple of them, just a couple of easy ones maybe. Let's go to this one that we just did. So let's say I had a negative 20 degrees. What would be its coterminal angle? So if I went from this green all the way around to 270, then since there's 90 degrees difference in here, I would need to go 70 degrees in order to end there. So what I would need to do is take the 270 degrees and add 70 more to it in order to end at the same terminal side. So that's going to tell me that it's 340 degrees. So the actual coterminal angle with negative 20 would be a positive 340 degrees. That would be the one that I would be looking for. Let's pick another one just for fun. Let's say we had a 40-degree angle. So if we had a 40-degree angle, and if you needed to draw yourself a picture, it's perfectly fine to do that as you get used to doing this. So we're going to draw another one here. And if we drew a 40-degree angle, that one's here. So we'll put our here's our initial side, here's our terminal side, and what I need to do is I need to figure out which angle, there's 90, 180, 270, and I need to figure out how much is left. So if there's 40 taken, it means there's got to be 50 open. So I'm going to take the 270 and I'm going to add the 50 degrees to it, and that's going to tell me that this is 320 degrees in order to make a coterminal angle. So the negative, and remember that it's negative because I had to go the opposite direction. So if I move in the clockwise positioning, those are negative degree angles. And if I go in the positive or the counterclockwise direction, that's where I'm going to get my positive angles. Okay, there's two of those. Now you can do any angles that you want. They all have coterminals. And again, you are not limited to just spinning around one time. Maybe you wanted to spin around another time. So whatever you find, if you add 360 to it, so if I went here and I added a negative 360 to that, I do have another coterminal angle. So if I did, it would tell me a negative 680 degrees would also be a coterminal angle. I can add as many. So if I added another 360, then I've gone around another time in the negative direction. Okay, now what are we going to be using all of this for? So I'm so sad that we aren't together and I can't teach you these things in person because there are so many uses for trigonometry. So many people are using it in the world today, believe it or not. So hopefully some of you will be inspired to study this more completely. And some of you will be using it in your engineering jobs in the future. So here's what we're using it for, just the very basics. So we'll be using trigonometry with what are called the rectangular coordinate system. So all that means is you're going to be using this coordinate. That's what's going to tell us, and I'm going to erase all that. We're going to be using that coordinate system in order to draw what are called reference triangles, so that we can do some calculations. So if we were to draw a 30-degree angle, so we're going to pick our color red. If we were to go to a triangle that's drawn on this regular rectangular coordinate system, if we were to call this 30 degrees, then you can see that we can drop down a perpendicular line anywhere we want, as long as from here to here. So my initial and my terminal sides form a 30-degree angle. Then I can choose where I drop a perpendicular. I can drop it anywhere we want. Okay, so I've just dropped a couple. So we have BF and BA. They all are perpendicular to this ray CF. If we do that, and remember if it's a 30-degree angle, remember that we have some lengths here. So if we did our lengths, the first thing that I would need you to see is that if we use BA over AC, then what the length of that would be whatever length this is here, we would call an X, and whatever length that we had up and down, we would call a Y. Now, what we call between C and B, we call an R. And what that comes from is your Pythagorean theorem, that x squared plus y squared is equal to r squared, Pythagorean theorem. So my BA over AC would give me a ratio of remember that if we're doing 30 degrees, that we're using this. We're using so, ka, toa. So what we're going to use then is what's called an x over y, a y over x. So my 30-degree angle is going to have a ratio of a y over an x if I were using a BA over a CA. If I were using a CA ratio over a CB ratio, it would be an x over an r. Now, I'll tell you what we're doing here is if we know that we have a 30-degree angle, then we can use any of the ratios we want, sine, cosine, or tangent, according to the length of x, the length of y, or the length of r, the length of AC, AB, or CB. The last one we have is BA over BC. BA is y, and BC is r. So we would have the ratio y over r. Now, if we were to understand what this means, a BA over an AC, so a y over an x would be, in this case, it's an opposite over an adjacent. This would be the tan of 30 degrees. If I used the ratio of CA over CB, this is adjacent over hypotenuse. And adjacent over hypotenuse would be the cosine of 30 degrees. And then if we wanted the final one, BA over BC, BA is over BC is an opposite over hypotenuse, and an opposite over hypotenuse would be a 30 degrees. So the sine of 30 degrees, opposite over hypotenuse. Now, each one of these ratios we are going to be able to use, excuse me, to find out what the lengths are. Now, the exact same thing is true if I move out a little bit to EF over CF. So if I move out a little bit, let me change to a different color. So we would still call, now it's a different reference triangle, but it's still going to give you the same reduced values as you would if you use the tan of a smaller side. It's still going to be the same thing. This is still the length Y. From here to here is still the length X. And this is going to be a new length of R, only because we've used a different triangle. Now, you know that there's similar triangles. So similar triangles, remember, are going to have corresponding angles congruent and corresponding sides are proportional. So the values are going to be exactly the same no matter which reference triangle I use. So your EF would be a Y over an X. Your CF over CE would be an X over R. And your EF over EC, so EF over EC would be an opposite over a hypotenuse, would be a Y over an R. Now, again, this is still going to be a tan. This is still going to be a cosine. This is still going to be a sine. Each one of these was at 30 degrees. Okay. Now, whether you went to 30 degrees, 45 degrees, 60 degrees, it makes no difference as long as you're using these same ratios. So what do you notice about these ratios? And is there anything that you have noticed that I didn't already tell you? Because I usually can't hold the secret in. These are the ratios of sine, cosine, and tangent. Yay. And that's what we want. So what we want, our goal is to allow you to be able to calculate a reference triangle with minimal information that is given to you. So your sine, just in case you've forgotten, remember, this is what we learned in chapter 1. It's SOHCAHTOA. So once you have your reference triangle, your sine is opposite over hypotenuse. And if we looked back, if we wanted a 30-degree angle, My opposite would be y, my hypotenuse would be r. So you have a couple ways you can remember this. It's either a y over r, or you think opposite over hypotenuse. If you wanted the cosine, remember, is the adjacent over the hypotenuse. So it's an x over r. So do you see where we're getting these ratios from? And then the last one, the tangent of theta, is opposite over adjacent. So that's where we get the y over the x. Now, don't forget, we also have their inverses as well. So the inverse of a sine is a cosecant. So it's really simple. You'll notice that what I did was took the reciprocal of the ratio. So instead of me having a sine, I now have a cosecant, and I take the reciprocal. It's a y over an r, which, remember, it's hypotenuse over opposite. The secant is the inverse of cosine, which means you have to take the reciprocal of the ratio, r over x, or hypotenuse over adjacent. And then the last one is tan, which is the reciprocal of cotan, which means you have to take the reciprocal, x over y, or adjacent over opposite. So whenever we get ready to do our reference triangles in just a minute, I need you to remember that x is the x-coordinate length, y is the y-coordinate length, and r is the distance that x and y coordinate is from 0. We will be using the Pythagorean theorem, x squared plus y squared equals r squared. All right, I'm going to stop here. I'm going to upload this video, take a quick break, and then I'm going to come back and do a couple practice problems so you can see how to solve for your 6 trigonometric functions when I give you an ordered pair in standard position. The reason I'm going to stop it is because it takes so long to upload videos the longer they are. So thank you very much. Take a quick break, and we'll be back shortly.